Hello everyone, this is Sam Spade and welcome to another Coding Fundamentals in GML tutorial. In this tutorial we're going to be talking about custom data structures. So, as I've said ad nauseum at this point, a data structure is a collection of data, the relationship between that data, and most importantly, how you interact with that data. GML has several built-in data structures, which we've already talked about, but, and this is the key part here, you can make your own. And really, I think this is a very important idea because so far we've only been dealing with data structures that are given to us. Arrays, lists, maps, and so on. GameMaker just gives us these and tells us how we can use them, which is great. These are very important data structures, but it also makes data structures maybe seem a little bit mysterious as these sort of unknowable things that you just interact with. And hopefully creating some of your own data structures will give you a better idea of what they really are and how to use the built-in ones, as well as how to make ones that will be more useful to your needs. When you make your own data structure, you're defining what the data is going to be, how that data is going to be stored, and how you're going to interact with it. And generally, you're going to build it on top of another pre-existing data structure, such as an array or a list or a map or something like that. So why would you do this? Why would you build a data structure on top of another data structure? Well, the primary reason is that when you do this, you're creating an abstraction. And by doing so, you're allowing yourself to easily interact with that data in a way that is convenient for you. And because it is easy and convenient, it gives you more flexibility in your code. It allows you to maintain your code easier. It allows you to extend that code and transfer that code from one project to another. Essentially, it allows you to do more things with your code. So we're going to create a very simple data structure here. It's going to be a shuffle stack. That's just what I'll call it. I'm making it up completely because I want it to be very straightforward. It's basically just going to be a stack that we can shuffle. Now, you wouldn't normally want to do this. That sort of defeats the point of having a stack. But again, it's a very easy data structure for us to make and allows us to focus purely on creating the data structure rather than also having to learn a bunch of new things as well. So we're going to store data as a stack. And we're going to have the following means of interacting with that data. We're going to have the ability to create and destroy the stack, push and pop, get the size of the stack, and most importantly, shuffle the stack. And we're going to build it on top of the DS list. So I'm going to switch over to GameMaker Studio 2 and let's walk through this code. Okay, so before we run the code, let's go over it. So I will go over all of the actual scripts in a moment, but first I want to demonstrate what having them allows you to do. So basically, we can say create a stack. Then we're going to push some values onto the stack, and then we're going to shuffle the stack. And then, just as we did in the stack tutorial, we're going to go through the stack and pop all that data off, and then destroy the stack. In fact, if we come over to our data structures and look at the stack code, you'll see that it's actually very similar. We're doing basically the exact same thing, except that we're adding this shuffle in here, which is something you can't do with a normal stack. And this is the power of creating your own data structures. Now, this data structure is admittedly a little bit silly. It doesn't really give you the ability to do anything except something you probably wouldn't want to do in the first place. But just as an illustration purpose, you can see how we have now created this whole new set of functions or scripts that we can use to interact with data in a way that is convenient for us if we did want to do this thing where you shuffle the stack. So now let's just walk through these stacks to see how easy it really is to create this custom data structure. So as I said, we built this on top of the DS list. Since it is a DS list, we'll need a create and destroy. So here's our create, which is just a wrapper script for the DS list create. Here's our destroy, again, just a wrapper script for the DS list destroy. We'll come back to push and pop. To get the size, we just have the wrapper script for DS list size. And to shuffle, we just have a wrapper script for DS list shuffle. So you'll notice that we basically just created a script and renamed everything. We'll talk more about why this is a good idea to do in some circumstances. But now let's get to the heart of a stack, the push and pop. For push, we're really just going to insert the new value at 0. And then to pop, we're simply going to remove the value at 0. So we're going to get that value, save it to a variable, then delete it from its list, and then return that variable. So this allows us to push data on and pop data off, getting the data in a last in, first out way, which is what a stack is. So before I talk more about the sort of philosophy behind doing it like this, let's just run through it and see if it works. Okay, so we're not going to step into any of these scripts. We're just going to pretend like they're built-in functions. So we create our stack, And again, remember it's actually a list, so we have to say view as list. So currently empty. Then we're going to push some data on. And as you can see, 45210, 45210, it's getting pushed onto the stack. So the number that gets pushed on first goes at the bottom of the stack. And the last number to be pushed in, 10 in this case, goes at the top. When we push in 1, whoops, I stepped into this one. When we push in 1, it gets added to the top. When we push in 6, whoops, we push in 6, there we go, gets added to the top. And now we'll call our main function, the one we wrote this for, stack shuffle, and we'll shuffle all of these values. There we go, they've all been shuffled. And now we can just go through our stack and pop everything off. So we have our value. We'll set it to undefined each time so we can see that it's changing. Get our next value, and you can see, just like with a normal stack, it's being removed from the stack. When you read the stack with stack pop, it gets lifted off of that stack. And we go through it all, it's all done, and now we destroy it, and it's an invalid structure. So why would you even want to do this? Well, again, this is, like I said, a kind of a silly example. You probably actually wouldn't want to do this. But if you did, you could just use the built-in functions. There's really, in one sense, no reason to create a bunch of wrapper scripts. Really, all we're doing is renaming it. But the advantage to renaming it is that when I've done it this way, I have now constrained what I can do with this data. You know, when you're working with a normal list, you have all sorts of things you can do with a list. You can insert at any point. You can add to a list. You can delete or remove from a list from any point. You can sort a list. There's a bunch of different things that you can do with a list that we don't want to be able to do with this data structure. And so when we build the data structure this way, what we get is a constrained set of interactions. So whenever we're working with our custom stack here, we know exactly what we're allowed to do with it. We don't have to remember which list functions we are allowed to use and which list functions we are not allowed to use. In fact, we can even forget that this is built on top of a list. We can just use it purely as a stack that you can shuffle for some reason. And again, for an example this small, it's kind of silly. But as you will see when we build larger data structures, this is incredibly helpful because it allows you to forget about the implementation details, how you've actually done it, and just use the thing itself. And that becomes incredibly powerful. So in summary, a data structure, as we have said ad nauseum, is a collection of data and how it's arranged, and most importantly, how you interact with it. And you can make your own, which you will generally build on top of another data structure, such as a list in this case. And this lets you do more and do it more easily. The links in this slide will be below. There's not very many links in this one, but it's probably worth going to Wikipedia and looking at some of the real data structures that do exist, understanding how they work, and maybe even thinking about how would you build this yourself in GameMaker Studio 2. The slides and source code will also be linked below, and that's it. Thanks for watching.